with two separate classes, right? Yeah. We have the program class, and then I have the car class on the other side. Okay? So let me open that car class back. And I will put this like over here. Okay. Remember this car class. Think of it as a template to build a car. Yeah. This is another class here. This is also a class. Although we just call it main program. This is a separate class, exactly the same as car. Okay, it happens to be the main program because it has the main method in there. I could completely move this around and make the car class as the main program if I want to. Okay, so when you have two classes like this, one is the main. Inside the main program here, I can reach out to other class like the car class and then create objects out of this class called car in this program. Okay. Yes, the car, the object itself, it could be any car you want, any object. But this is a blueprint on the right side. It's a blueprint. For the information. Yes, for that car. Mm-hmm. And then when you create a very specific car, you give it a very unique name. This car is a Mustang. I could create another car, call it Ford. Okay, but it will have the same blueprint.
So this is just so that you can. So this side is like any combination of make, model, and whatever, and then this is just saying for this specific car, I need the VIN, the make, model.
Yeah. So for a very specific car Mustang, you must have very unique data for the Mustang only. If I create another car down here, for example, I call it, so you have to create another car manually like this. This may be called a Ford. Okay, so that called Ford actually a little bit more, should be a little bit more specific. Ford is not a car. I don't know, a GT or something, right? And so this car also has exactly the same data fields, but it has its own unique data.
And then when you set those numbers, does that change per car?
Yes, it changed for that car only. Okay. So GT has its own data. You think of this like the real car in the real world. No two cars have the same VIN number, right? Exactly the same. So I mean, program I can force both parties to sing the number, but typically you don't want to do that, right? Okay, so these two very specific cars, has exactly same design, except these data will be different for each car.
Yeah, but you haven't necessarily populated all those variables, data fields.
Yeah, right. Unless
How does it know that Mustang is assigned
to they have their each, like for each car, do they get their own
Yes.
Or
so
just use the same one,
yeah, using the same template, like when you want to make the car. I want this car to have this VIN number. I want this car to be green. This car to be red. But it's the same design. Okay, so exactly the same thing. When you instantiate a car like this with a new car like that, it gets a real object of this class called car. From there on, that Mustang lives as an object in the program world. And if I create another car for GT, that also comes alive. So you have two separate car objects, and they have their own unique data. One could be a Ford, one could be a Toyota, doesn't matter, right? But it has exactly the same information.
So the object relates to a record in the database. So over here you've got the same layout as fields in the database. And here you're creating a record and you're either creating it, changing it. I mean, is that the same?
Yeah, so when you create an object of the car class, from here on, so the Mustang has all these properties attached to it. Okay, attached to that, so we have the dot notation going to give you that it's attached to the car called Mustang. Okay, so all these functions in here are attached to this object called Mustang. whatever this class car has, the Mustang has all of them. And to use it, you just have to call those functions. And you call those by using the dot notation because it belongs to that Mustang.
And so in database terminology, I'm thinking of the Mustang as primary.
Yeah, right. Kind of like that, yes. Hmm? Yeah. So you think of a yeah, it's like a ball and has all these appendages coming out of the ball. Okay, each of those lines represents one of those data. So if you make another car, it's exactly the same as that design. Okay, and so once you have those, once you create the car object, like let me delete this one for now. From here on, after line 9, line 10, if I call it Mustang, it will have these data created inside the Mustang object. Because initially in this class here, I did not assign any data to it, so they have some default data. Okay, the default will be like this one will have default to same thing as saying the empty string. There's no data attached to it. So that's why we have to set the data so that the Mustang has its own data, okay, uniquely to itself. If I have another, like I showed you earlier, GT will have its own data. GT have to also set its own VIN number, something like that, whatever it is. Okay, so they have their own separate data because they're two separate entities, objects. Yes. It's floating in RAM. So if you create a lot of objects, a lot of RAM data will consume RAM. You have memory issues. Yeah.
So
Yes.
you set it in the main program and then call it from
The class. Yeah. Yeah. You can think of it that way. It's like once you create the car here, and then I'm setting that VIN number, I'm calling the function called setVin. It's going to go into the class called car and find a function called setVin. It must be in there, otherwise you cannot use it. Okay, so, yep. Yeah, so this function only sets the data VIN to this one for that car. This one here has a different car. It will set its own VIN number because it has all these copies in here to itself. So you have two separate objects, have the same fields, you have your own data based on how you set and in here. Does it make sense a little bit now?
Oh, so our car.java is in the same package. So
Yes.
we don't have to
Yeah, it's the same package, so you'd have to make any import. Yeah. Question?
So once you get the information, once you get the VIN, where does that go?
Okay. So now, once you create the car, you set the VIN number for the car. So we know that because we see it, right? We know that a Mustang has this VIN number. And if you want to get it back so you can use it, so you can display to the user, that's when we create another function to get it back. Okay? Because this way you cannot get it, because this function returns void. It does not return any data. You only pass data to it, set it, you're done. To get it back, you have to write a separate function. That's what we call this is the getter. Go and get it for me. Get what? Get the VIN number. Return the VIN number I set earlier back to me, whoever wants to use it. So when we get it back, that's why when the data comes back, where does it go? Right? So it has to go somewhere, and that's why you have to create another variable to store the data so you can use it.
So then you give it to someone, and then it goes over here to get it, and then it comes back over here
Yeah.
to sit here and wait for you or something like that?
Yeah, it sits here. So now, okay, here's the data. Who's going to keep it? Oh, give it to this variable called VIN to store that in memory. So now, if you want to print that out, then I can go print. I show that I have the print function here, right? It's a string. So I could put print VIN. So now we can print the data out to the user. They can see it. Or I can do something in the main program. I could, check the data, make sure it's valid, or if it's a number or something, I can use that to calculate some data, and so on.
So the only issue I see is no mod 17 you described that string then that have to be a variable.
Mm-hmm.
Now when I want to go get it for your GP,
Mm-hmm.
I need a different variable name.
Yeah, so, right, so if you only use it once, if I get the VIN out for the Mustang to VIN, I print that out, I'm done, and then the next one I can do the same thing. I can reuse that again to get the GT.
Sure.
Yeah. But if I need both of them, then yeah, I need two separate variables to store each. Okay. Yeah, so very, very good.
Yeah, so the instance of the object is basically the primary key. That instance name is Mustang.
Well, the object would be like the actual entity out of that table, and then the VIN would be like the primary key. Yeah, it's a unique key that makes the car unique. It's the VIN number, right? That'll be the primary key of that table called car. Yeah. Yeah. That's okay.
You don't actually assign any
Data.
data to this class. It's only assigned in the main program.
Well, you have a really good question, because now that's something you have to think about. When you create this template, do you want these data to be pre-populated with some default settings or not? Maybe like when you create it, I want all the car to be of type Ford. I don't know, right? So if that's the case, then you will say, oh, I want this string that every car I make will be of type Ford by default. And so if you do that, then you don't have to set that anymore, because when I create the car Mustang and the GT, they'll all be Ford.
So then it would just be, then you would have to set the VIN, the model, and the year.
Yeah. So the Ford, it's already set. But you can still override if you want,
Right.
because
Something that's perfect.
yeah, like you make another car. Maybe this is not Ford, maybe it's a GM. Okay, I can still use the blueprint, but I want to change the make to say GM instead of Ford. Okay, so that's,
How would you do that?
I'll just say set make, right?
On the left side.
Yeah,
Set.
yeah, because we have the function to do the setter and getter, right? I think I had it before. I probably removed it. And you just call it set make, and then you pass in the string. Actually, I deleted it somehow. So
You may make a private static string.
a private static. Yeah, you can. If you make it static,
You would have a setter. But it wouldn't
you still can. Yeah. But it would make sense, because if it's static, it would apply to all cars. Yeah. So if you make it, yeah, not just the Mustang, all the cars you make will have the same VIN number, and that wouldn't make sense. Yeah. So if something that can apply to that, maybe the make could be static. If you want all your cars to be Ford, then you make that static. But yes, you can set to static. So to set the make, you would say here, same thing, right? I would say like Mustang that set make, and then you pass in the make, and then this would be like Ford or whatever brand you want to put in here. Okay, so that's where you have the setters and getters. I want to set the model. I have to set the year as well, because I did not set those in here. So if you don't set it, you get some default data. Okay? And that is the world of objects, folks. Objects. Okay?
Yeah.
Think of an object is a separate entity. You're gonna have two objects that are the same, exactly same. You can like two balls. It's different in texture, different in how they are made. So that's what all these properties describe your object of a very particular object out of this blueprint called car. It's just a blueprint. Okay. So great questions. So typically when you create a template like this, if you don't supply any default data, once you instantiate the object, you will have to set all this data first before you can use them. Otherwise, they are kind of useless too, right? So set them all the data, and then from there on, you can do things with it. Maybe you want to change something based on certain criteria, right? Yeah, you can request. Right, so you can write a program and say, okay, I got a car. What should this car be? They enter Ford. Okay, you set that in there. What's the year? They enter that in. So it's like if you go to DMV, you have a new registration card, you have the form. Exactly, that's what they do, right? Entry, data entry.
Yeah, so you have a form and you form validation method to make sure you fill in all
Yeah.
the variables.
Also variable. Not only that, you have to validate, make sure that.
Model is not filled in.
Yep. You have to make sure that they also be a current, a certain data, like the year, or either 2 year or 4 year has to be a certain year. It can't be like 1910, right? Yeah. Yeah. So you have a validation whole process to make sure that also gets to. Okay. And then of course, then once that's good, you have to send these to the actual database, which we haven't done. Okay. So.
Yeah, don't do a post method form validation.
No.
Because the form validation function goes to the post function.
Yeah.
And that causes lots of problems. But there's
Absolutely.
Northwest Virginia.
Question?
Number 2.
Yeah, we'll try to print any one of these.
You'll pop your screen up.
Mm-hmm.
You Chromecast.
There we go. Yeah, it's cannot find symbol. Symbol is method print string.
Well, the print, you have to have the print function down here. If you didn't have it earlier, it wouldn't work, right? I had it because I had it. Otherwise, you would do a system out.
Gotcha.
Yep.
I got
Yeah.
that.
Oh, okay. Yeah. Yeah. So this one, if you print it out, I gotta get just the VIN number because that's what we print. We get the VIN number for that car. Okay, so let's see, back to the car here. Go back, if it lets me go back. So back to the car, we got the 4 data fields, they're all private. And the reason we set it private is because we have, like he was saying, you can validate the data usually, right? Make sure that the numbers are correct, the data is valid, the VIN numbers are certain, the characters long, and so on, right? So you have those type of function. You can check inside your code here if you want to. Versus if you make this public, if I make like the year public, for example, if I do this, if I public year, okay, then in the program here I could change the year for the GT.year. It's available because I make that public. I could change that and I can have the year of maybe like 1, 2, 3, 4. It doesn't make sense. So there's no way to validate that data because you have access directly to that variable called year. Okay, so any user can do that and there's no way to check it.
And there's no way to put a form.
Right. They might put only 2 digits, right? Or just 1. And then now you have data inconsistency, so you have integrity issues. Okay? So that's one issue. Another is if you have a lot of these, if you have a lot of these here, right? We call it get year, whatever it is. And then the programmer like yourself, I'm going to say, oh, I'm going to change that to call the year make. You change that data name to year make, and now everywhere where you use the actual name is no longer valid because you changed the data field, and they will find it and change all those 100 times or 1,000 times, wherever they are. Okay, so that's why if you use just one function called get year and set year, if I change that here, well, I only change in 2 places, right? And I don't have to change about the set and the get at all. Okay, so that's why you set it to private, and then you access it through its public function. Okay, so now we got the setters and getters. These are all called setters and getters. And let me move all of these down here to the bottom of this list. The next thing I want to talk about is this thing called constructor. Okay, a constructor is a special function that construct an object out of this class. Okay. And you see back here the main program. When we create the car, the Mustang, right? It has car Mustang equal new car. This is a function. The capital C for car, the same with the class, followed by a parentheses. That's a function call. Just like we'll make the function call for the print VIN and the get VIN and so on. Now, where is this function? We don't see it anywhere in here at all. We didn't create that. So what does it know, right? So if you don't create that function explicitly created in the code, Java will create one for you automatically, okay, behind the scene. So Java creates that blank function, and that will look exactly like this: public car, and then you have like that. So you notice that there is no data type between the word public and car. Okay, you cannot put any data type between there. It has to be the word public and the word car, which is the same name as your class. Okay, it has to be exactly the same. Word for word, character for character, uppercase, lowercase, you got to match exactly. And then a parent just like a function. So this is a default constructor. A default constructor is a constructor that looks exactly like this, has no parameter, and it's empty inside the body of that constructor function. Okay? So because we didn't create this earlier, Java created one for us, but it's calling this function called car, like right here, new car. Okay? So that's a constructor. So with this constructor then, you can do a lot of things. You can initialize these data fields like you mentioned earlier. Can I just make that to a Ford? Yes, you can. Okay, so instead of putting up here like this, you could go into the code here and say, well, every time when I create a new car, I'm going to go and make this car a Ford. So you can set up the data in here and make all these. You can initialize all these data fields to a specific type of car. So that it's not blank, it's not empty. I mean, of course, sometimes it doesn't make sense, but you can. If this car, you can say, maybe not just car, you can call like Ford or something. Then the make will be all Ford, right? And that'll be
all kinds of elaborate code there to prompt the user to ask for.
Yeah, yeah. Okay. So this is a constructor, and you notice that down here, you see the word this in front of it. Okay, this.make. Here I did not put this in front. I did not put here either. But this IDE tells you that if I click on the word make, it highlights this word up here as well. So it's a global variable that is reaching out to the word make. So if I have another variable, for example, if I call it string make in here, remember this is a function as well. So this is a global variable. This is a local variable inside the function called car. And now you can see that when I mouse over this or check this, it does not highlight this anymore. Okay, because it looks for a variable called make inside this local function. If there is one, then it's going to stop there. It will use that as a variable. And if you do this, this variable up here will not be called assigned to the word Ford. It's just assigned a local variable down here. Okay. So this is why it's important to use the word this in front. A good example will be this VIN down here. Typically, for your getters and setters, when you do the set, the variable that comes in is always the same as the one you set up here. By convention, you don't have to call it that, but it's usually the same, exactly the same name. So here I should have called this like with a capital VIN. And then this is a capital VIN. So now, since they are the same, you see that there's a conflict there because I'm assigning to itself. The VIN here is just itself here assigned to itself, so it goes through this cycle, right? Doesn't make sense. It does not assign this VIN number to the one up there. So to leave outside of this local function, to go outside of this, to assign to this VIN outside here and not the local one, you have to use the keyword this in front of it. Okay? So the keyword this would call the global variables and not the local variable. Just in case if you have two exactly same variable inside, because you can. Yeah. It will reach up, so it will assign this VIN number, which is a local coming in, and then assign the data to the VIN, which is the same VIN, but this one is now assigned to the global variable. Okay, so that your data will stay in the with the object.
When you say global variable, global to this specific class.
Global to this specific class, yes. Mm-hmm.
But later we'll ask you
Yeah. Yep, that's right. So that's why if you scroll down to see the ones that we made earlier with the IDE, it comes in as a make, and this make equals that make comes in, the model, the year, and so on. Okay. And of course, again, there's no rule. You can make this a different variable called X, and you'll be fine with that too. But usually it's the same name. Okay, so back to this constructor here. So you see that with the blank constructor, I can change some, I can assign some data. Okay, so I'm going to remove this back out again. So let me save this. I just make the word Ford in here. And because I assign it to Ford, so now both of these cars are Ford. And when I print the here the Ford, so I can do another string. You can do like string here, make is equal to Mustang dot get make. Get the make of that will be Ford. And then I can print that make to the console. Okay? And if I run it, you'll see that it has ABC123, that's the one that we set. And it has the Ford as the make because it's assigned, or we set it here, but I should have set that one. Turn that off.
back in the main program class, so that then make variables are global to that class.
Mm-hmm. Yeah. So that's why it's Ford. GT will also be Ford. If I put like GT here instead of Mustang, GT, you will get Ford because GT is also Ford. When we create the object of GT, it's assigned to Ford. So that is a constructor. This is one constructor. Okay, you could have another constructor that can take some variable, just like the function here. It takes a string. So that when you make a car, you want to do something like this. Instead of calling the set every time, what if I just want to make a car? Let me comment these out. I want to make a car that would do like this. Let's say car, my car is equal to new car. I want to pass in the make and model of the year right away in that function call. I want to make this like a VIN will be like you know, maybe 333 TRY. That's a VIN number. I want to pass in the make will be a GM, and then I don't know what kind of car it is. What type of GM car is it going to be? Any model? What?
GM, there's so many models, so we'll just call her the
Tahoe. There you go. Yeah, Tahoe, and then the year would be like, let's say 2018, 17. Okay, 19. It is. Okay, so you can pass these four variables to that function when you create the car instantly, so that you don't have to go set something 4 times. Okay.
So how you read that car is the class you're calling?
Yeah, I'm calling the car class. I've created a car type called my car, and then create a new car out there. I'm going to pass the data directly to that function, and this function doesn't exist yet. Okay.
Where is my car? My car is in the Java.
My car will be just like Mustang.
So it'll be.
It's the object. It's the actual object.
But it's in
Yeah.
another tab, right?
Yeah.
You gotta write a new constructor
Yeah.
to handle
So this is exactly the same as this, except I'm filling the blanks, the empty here with some data. I've got to pass some data to the function. Okay, so now it takes in the VIN, the make, model, and the year. So now in my class, I don't have that here. So you can go and create one called car, and then you take those 4 parameters. And we said the first one was as a VIN, so I have to say the string of VIN number. The second parameter was a make, and then model, and integer of year. So now I have a function, a new constructor, that takes all 4 parameters at the same time, one time, and then once I get those data coming in, just like our join to string functions, I get 2 parameters comes in, I can do something with those data. Okay? So here I have this data coming in. And if you look at this, set the string, it's exactly the same as this. So I can say this VIN is equal to the VIN coming in. Okay? This make is the make is passed to me. This model is the model coming in here, and this year is this year passed to it. So I instantiate a car at the same time. I set their data in the one line of code.
So how does it know those 2 constructors are different, other than the fields within it?
Yeah, that is the key. The fields, I mean the parameters they receive. Okay, so if you call the one that has no parameter, it's gonna call this one. If you call the one that has 4 parameters, it will use this one.
So you had just the string VIN make model. It would be like input the year.
No, you have to make that one yourself. Yeah, you have to make
So
a
it would go back to the default.
yeah. So you have not only have 2 options. Okay, so I can either use the blank one or this. Okay, if you want to make another one, let's just say, you know what, I don't want to pass the year, I just want to pass those 3, like maybe my car 2 or something. Then you have to go make another constructor that takes only 3 of these variables, and you cannot pass in the 4th parameter. Okay, so I could have another one just like this, and that takes 3, and then maybe you don't have the year to it. And because I do not pass the year, I cannot instantiate the year, so it will be just blank. It will take the default, whatever it is, it will be blank. So now I have 3 options. I can use the 4 of them, here's the 3, or the none. Or you can have another one, just take 1 or 2, right? So however many options you have, you want to pass to, you can have as many constructors as you want here. Okay, and this is what's called a polymorphism. Okay, polymorphism is the same name everywhere, many forms, many signature. We call if it's a different signature, the signature will be what's inside these parentheses here. If it's a different signature, different data type, different amount of parameters, then that is a valid function. And you can have as many as you want, as long as they're unique. Okay?
Well, so of course a good program will put lots of comments around there, but why?
Yeah. Yeah.
So,
Yeah. So,
practice is nice.
yeah, only thing is that make sure that it does not know VIN from like X. It doesn't know that. All it knows is that the data type is called string, data type is string, and int. Okay, so if you have another one here, say if I have like exactly saying, you see that it doesn't work because it's duplicates. It doesn't mean like, oh, if I change that to a different name, then it'll work. No, it doesn't. It doesn't care about the actual variable name. It cares about the data type. Okay, so the data has to match. I mean, it has to be different in that order. So if I put the int first, then that's valid. If I put int in the front instead of the last, if I make it in the front so that it's unique, then yeah, that's valid because it's different. It's no longer the same footprint anymore, right? It still takes full parameter, but you pass data in a different order.
So it's the order.
Yeah, the order. No, not the order they are called, the order inside the parameter. Yeah. The order, I can put this in the very bottom. Any order doesn't matter in terms of where they are placed in the code. But the order inside here is important. So this is called the signature. And this applies to not just constructor, applies to all your function as well. Okay? So this is called polymorphism. And what we did here is also called the constructor overload. We will talk about this in many more lectures to come. Okay? So constructor overload, because I'm overloading the constructor. Again, constructor is a special function that has the same name as the class, and that is used to build an object out of the class. Okay? So constructor overload is only for the constructor. If I use exactly the same thing for the functions, then this will be called method overload, because I'm overloading a method, a function. Okay? So once you have those options, then here I create two cars, and they're already instantiated, and they assign the data right away. So I don't have to say set VIN, set make, set year, right, anymore. If you know the order, it will tell you anyway, but you know the order. It doesn't mean, okay, so what if I want to change after that? Well, you can still access those functions. Car, I can still set the make to something else. If I don't like GM, I can change it to something else. I don't know, BMW. You can still change each of those fields individually through those functions or those setters and getters. It's not overriding, it's using.
Well, because you said you set the make with BMW, where in the other one you set it as Ford.
Oh, here?
Was that?
Yes, it will. Yes, initially it's for GM.
Correct, yeah.
Yeah, after that I change it to BMW, so from here on it will be BMW
So
for that
in
car.
This is what's primary. This is what it will.
Yeah.
It's in the main.
Yes, it's in here because remember this one is just a blueprint. Okay? A blueprint. When you make it the object, this is like it's no longer important anymore. It's no longer because this object has all those already attached to it. And you can take this object and go anywhere, and you can change its data anytime you want. It's not going to affect the original data in the class in car anymore because that was just a template. Okay? So does that make some sense? Objects. Okay. So once you have the template, you can make as many objects as you want out of that classical car, as long as each object is unique. So I could make 10 cars. And then later when we learn about arrays, you can have a list of cars inside one variable, right? Arrays. Okay. So the first car will be the index 0. Second car index 1, index 3, and so on. They have their own car. And so you don't have to have 10 lines, but just one can contain 1,000 cars. Okay. So that's what you do, like if you own a dealership, that's what you do, a list of all 1,000 cars. You track each car by each index. Right? But before we understand that, just make sure we understand the concept of creating objects out of these classes. So a class has data fields. Again, just set it to private. If you want to set to public, make sure you have a very good reason why. Otherwise, it's always private. And then you need to supply a constructor. If you don't need one, then just leave it out. It will always be the blank constructor by default. If you want to add something to it, then you create your own. Okay. Just remember that once you create a constructor like this, and if you don't supply the blank one, so if I were to delete that out, okay, I don't have the blank one, this will not work. Okay, as you can see, no longer valid. So Java doesn't allow that. Either you have it or you don't. Okay, so if you have one constructor in here, then if you want to use the blank constructor like this, you have to explicitly create it and put it in here. Otherwise, Java will not provide that for you anymore. Okay, so that means you cannot use that. You have to use one of those three. So it's always good to create a blank constructor, and here I put 4, but you could have it so that it has nothing in there, just blank like that. It's for convenience sake. Like if you just want to create a car very, very quickly, just do that. Okay. So provide the constructor, at least this constructor, or 1 or 2, and then provide the setters and getters for those data fields so that you can use them in your code. And of course, these are just some functions that access and change these data fields up here, right? We do not write other functions in here, like start engine. That would be a function that inside a car, like, or turn. We make a turn left, turn right. Step on the brake, accelerate, right? We calculate the mileage of the fuel, right? So all those will be special functions that can apply to all cars. So you would go in here somewhere and write a function to maybe something like public void start engine, like that, right? And then you put a message, engine started or cars on, something like that. Okay. So this one has nothing to do with a parameter up here. We don't have a parameter called start engine, but it's just a function, right? So these are your methods, or we call these like behaviors. Okay, the car can do something. It can move, it can stop, it can stall, however you want to call it. So usually you have some related functions that are applicable to this object or this class called car. And if you have a different car, different type for like motorcycle, you might have its own data. Some of those will be very similar.